Alright, so now let's talk briefly about what regulates cerebral perfusion. What makes you get more blood and then less blood to the brain? And the answer is carbon dioxide is our main regulator of blood flow. So carbon dioxide is a metabolic waste product and you need blood to remove it. So then it would make sense that if you had higher amounts of carbon dioxide, then you would increase blood flow, because that just makes more waste, need more blood. It's a signal to your body to tell your brain, I need more blood flow to get rid of this. So let's do a little graph. But this is basically saying it's a proportional relationship between your partial pressures of carbon dioxide in the blood and your the cerebral blood flow. So higher levels of carbon dioxide lead to higher levels of blood flow. So it can be illustrated like this, okay? CO2. So high levels of pressure lead to high blood flow up here. Low pressure of carbon dioxide, so low levels of carbon dioxide, low blood flow. Very super simple. The other thing is that oxygen can also influence blood flow, but only if you have super low levels of oxygen. So if you're super hypoxic for some reason, maybe you took some was one of them opioids that make you not breathe, and your partial pressure of oxygen goes super low, then your blood flow will increase. So let's go backwards. So your pressure is doing okay, maybe. So let's say right here. So your blood flow is not changed by oxygen. This is oxygen pressures. Blood flow is not changed by oxygen. It's nothing. Doesn't really influence at all. And doesn't really influence at all. And let's erase this carbon dioxide picture first. So let's say this is just a normal level of blood flow from oxygen. And then once we get to a low enough pressure, it's too low now, super hypoxic, finally your brain says, oh shoot, I need some blood flow. So that's where it goes. So oxygen can influence blood flow only if PCO2 is super low, then you get high blood flow. Alright. The other thing I want to talk about is cerebral perfusion determinants. So we talked about all this stuff about carbon dioxide and O2, how that regulates it. But if you want to go to the physics of it, the physiology of it, there's a nice simple equation that tells you that the amount of blood that's going to go into your brain, which is CPP, is equal to the difference between your mean arterial pressure, so pressure in the body, and your intracranial pressure, so pressure in your brain. So this is all a pressure relationship. You need pressure outside the brain to be greater than pressure inside the brain for blood to be able to overcome the intracranial pressure and go into the brain. And this is, I think the key here is that this shows us why increased intracranial pressure can be so dangerous, why we do not want increased intracranial pressure, because if it increases too much, then it makes it harder and harder for blood to get into your brain and perfuse your brain. And then eventually, if you get to ICP equals to mean arterial pressure, then your cerebral blood flow is 0 and you die. You're probably dead before then, but for sure you're dead now. Alright, so that's it for our cerebral perfusion.